In today's lesson, we are going to learn how to write parallel and perpendicular equations. First, let's start off by kind of defining what parallel equations are. Parallel equations are going to have the exact same slopes. What they look like for parallel lines is going to be two lines that are perfectly next to each other that are never ever going to meet. So that's what our symbol looks like for parallel, two lines next to each other that would never meet. For perpendicular equations, they are going to have both opposite and reciprocal slopes. When I talk about opposite, I'm going to mean that we are going to change the sign. So given the slope, we will change signs on it. By reciprocal, I mean that we are going to go ahead and flip the fraction. That's what reciprocal truly means. The symbol for perpendicular is going to be an upside down T. That's what our two lines are going to look like, meeting perfectly at a 90-degree angle. Let's go ahead and practice given a slope, making it parallel. If the slope given is 2, the parallel slope is 2. If the given slope is -1/4, the parallel slope is -1/4. And you could put that negative either to the 1 or to the 4. Choose one, not both. Slope of -3, the parallel slope is going to be -3. And then if your slope is 7/5, your parallel slope is 7/5. That's really nice, but let's go ahead and talk about perpendicular. If my slope is 2, I want to make that slope have a perpendicular slope. The first thing I do is I change the sign. It was a positive, so now it's going to be a negative. I flip the fraction. If there's no fraction, you put your whole number always over 1, and then you would flip that to 1/2. Again, the negative can go to anything. I put it to the numerator. If I have a slope of -1/4, to make it perpendicular, I got to change it to a positive, change sign, and flip the fraction. Instead of 1/4, it's 4/1. We can simplify that down to just a positive 4 overall as its simplified answer. If I have a slope of -3, to make it perpendicular, I change the sign on it, negative to positive, and then I go ahead and flip that fraction. Well, remember, if it's a whole number, you can always put it over 1 to flip that fraction to a positive 1/3. So again, always remember that we change our sign here. If it was negative, we change it to positive, and if it was positive, we change it to negative, and then we go ahead and flip our fractions, just like we've been doing. Last one here, we'll do the same thing. The slope is 7/5. It is a positive 7/5. So I must change that to a negative. Then, instead of 7/5, I flip that fraction to be a 5/7. -5/7 is my perpendicular slope to the given slope of 7/5. Change the sign and flip the fraction. Now let's actually get to writing these parallel and perpendicular equations. For our steps for solving, we have step number 1. With the given equation, make sure the y is by itself before you move on to step number 2. Highlight that y, that is so important. We'll kind of highlight it in each problem to see if it's alone or not. For step number 2, we see if the question's asking for a parallel line. If so, we keep the same slope. If the question's asking for a perpendicular line, we have to change the sign and flip to adjust the slope. For step number 3, we plug in the correct slope m from step number 2 and the given point as x and y to solve for b. It's so important that we never use the y-intercept from the given equation. Let's go ahead and try this first one here. It says, for example 3, write the equation of the line that passes through -2, 7 and is parallel to the line. Step number 1, I'm looking at the y. Y is all alone by itself on that side of the equal sign, so we are good to move on to step number 2. The question asks for parallel. Since it asks for parallel, we're going to keep the same slope. Well, the slope in my original equation was a -4, so the parallel slope is going to be, you guessed it, a -4. Now that I have that slope, I can go to step number 3, which is plugging everything into y equals mx plus b we know. Well, the m is going to be our slope, which is -4 in this case. The x and the y are always going to come from my point. X comma y, the y is 7, and then the x is going to be -2. I bring down the b because I need to solve for it. Guess what? I cannot use the b on the first equation given. Only can pull the slope from that one. From here, all we got to do is solve for our b. Well, multiplication comes first. You got to combine those two numbers on the right side. -4 times -2 is 8. Then to move the 8 over to the other side, it's a +8, so we subtract 8. 7 minus 8 is -1, and that will be equal to our b. For our final answer, it did ask us to write the equation, so let's go ahead and fill in the equation. The equation is going to be y equals always. In front of the x is the correct slope, which is -4. And then after is going to be what we solved for, our b value, a -1. And that's your final equation. Keep your y and your x in the final equation just like we've been doing so far. For example number 4, we want to write the equation of a line that passes through 3 comma -1 and is parallel to the line x minus 3y equals 9. First step is looking at my y. My y is not all alone. It has x and -3 with it. So I go ahead and get it by itself by moving over the x term just like we did in our warm-up and just like we did before. And I bring down the -3y and sneak it in before the equal sign and the +9. Then from here, I go ahead and divide every single term by the number next to y, which is a -3. -3 divided by -3 cancels out to 1y. -1x, remember that's a -1 up top, divided by -3. Two negatives make it a +1 over 3 with x. Then 9 divided by -3 is going to be a -3. From here, now that y is indeed by itself, it is a parallel line I'm looking for, so I will pull a parallel slope. The slope is located in front of x, and to make it parallel, you guessed it, I keep it the same as 1 over 3. That's my slope. I will then plug into y equals mx plus b with the 2 points I was given. This is on to step number 3 now, if we're kind of following the steps above. For the m, I go ahead and plug in my slope of 1/3 that I just got to be by itself. Into the x goes 3 because that's the x value of our point given. Into the y goes a -1 because that's the y value that was given. And then we have plus b. I cannot use what my b was before. It's a different line. We go ahead and solve this out. Remember, when I have a fraction multiplied by a whole number, I can put the whole number over 1. -1 equals our 3 times 1 in the numerator, which is 3, and 3 times 1 in the denominator, which is 3, plus b. -1 equals 3 divided by 3, which is 1 plus b. I will then go ahead and subtract 1 over on each side here, leaving me with a cancellation of 1 minus 1 on the right, leaving just b. And then on the left, I have a -1 minus 1, which is a -2. We go ahead and finalize our answer by writing the equation, which is always y equals your slope in front of x, which will be a positive 1/3 in this case, which we solved for. And then you will add, or in this case, subtract the b value since it was indeed a -2. Let's go ahead and try some perpendicular cases. In example number 5, we want to write the equation of a line that passes through 4, comma 3 and is perpendicular to the line y equals 2x minus 4. First step is we make sure y is by itself before we move on to step number 2. Y is all alone on that left side of the equal sign, so we are good to move on to step number 2. Because the equation is reading that this slope needs to be perpendicular, I have to go ahead and do the perpendicular step of changing the sign and flipping the fraction. So I take the slope on the original equation, which is 2. To make the slope perpendicular, I have to do those 2 steps here. So I take that slope of 2 and I make it negative. It was a positive 2, so I make it into a negative. Then I go ahead and flip my fraction. If it's a whole number, I put it over 1. And that way, when I flip it, it is 1/2. So my new perpendicular slope is going to be -1/2. I go ahead and get rid of the old slope. I'm not going to use it again, as well as make sure you never use the y-intercept from the given equation, crossing out that -4 now. At this time, I can go to y equals mx plus b with my perpendicular slope. The m we just solved for, it's going to be -1/2 now. The x comes from our point, which is going to be 4, and then the y is going to be 3. B is what we need to solve for, so we go ahead and put plus b before drawing our line to solve. We go ahead and multiply a fraction in a whole number by putting the whole number over 1. The 2 numbers up top get multiplied and the 2 numbers on the bottom get multiplied. I'll put the negative with the 1, so that way when I multiply that -1 with 4, I get a -4. And it's now a positive 2 with 1, which is 2. I add b. From here, I divide that fraction out. -4 divided by 2 is a -2 plus b. To move over -2, that will be addition of 2 because I have to do the opposite, leaving me with 5 on the left and just b on the right. To write our final equation, we go ahead and start with y equals. In front of my x, it's going to be my perpendicular slope of -1/2. And then I will go ahead and add, in this case, my b value we just solved for, which is 5. Keep the y and the x in the equation, and then let's try the last example. For example 6, we want to write the equation of a line that passes through -5, comma 1 and is perpendicular to the line 5x plus 3y equals -21. Right away, let's start with step number 1 to make sure that y is by itself. For this equation, it is not, so we have to go ahead and get it by itself here. To get the y by itself, I must move the 5 and the x over to the other side. To move them both at the same time, I will do the opposite of a positive 5x, which is -5x. That leaves me with 3y equals -5x minus 21. Sneak in that x term between the equal sign and the number on the right. From here again, we got to separate the 3 and y. That's going to be with division. When I divide 3, I have to do to every single term. 3 divided by 3 is just 1y. -5 divided by 3 is a decimal, so leave it as a fraction. And then -21 divided by 3 is a -7. Now that y is all by itself, I can then move on to step number 2. Because in this question it's asking for a perpendicular line, I have to go ahead and change the sign and flip the fraction. So I'm going to take the slope of the original and make it perpendicular. To make this slope perpendicular, I have to go ahead and change this negative 5 over 3, to a positive change sign, and flipped 3 over 5. That's my perpendicular slope. I can now plug into y equals mx plus b. The m is what we just changed it to. Cancel out the original ones. The new perpendicular slope is 3 over 5. And then we go ahead and use the x and the y from the point given. The y would be 1, and the x would be replaced with a negative 5. It is plus b. Do not use the y-intercept from the original here. Got to solve for a new plus b. It's a different perpendicular line. We go ahead and start solving this out. Remember, to help with fractions, we put whole numbers over 1 to then multiply 3 times negative 5, which is negative 15, and 5 times 1, which is 5. Bring down the 1 and the plus b we did nothing with. Divide negative 15 by 5, that is just negative 3, and we have 1 plus b. The negative 3 will be added over to the other side, leaving me with 4 on the left and b on the right. For the final equation, we go ahead and write y equals. In front of the x is going to be our perpendicular slope, which is 3 over 5. And then after the x, we will have an addition of the 4 that's positive we just solved for. Now we're going to do some examples with Desmos application. How can I tell if the lines are parallel? Remember that they have to have the same exact slope, and we can count rise over run on the graph for both lines. So I want to find 2 nice points of my top line here. These 2 will work great. And then I count how far up, which is just positive 1, and how far over, which is positive 1 since it's 1 to the right. So that slope is going to be 1 over 1, which is simply a slope of 1. We then look at our second line. I'll use a different color here and find 2 nice points there. I'll count how far up, which is plus 1, and how far over, which is plus 1 as well. 1 over 1 gives me the same slope of 1 that my other line had. Another way you can look on Desmos to figure out if they are parallel or not is that the lines will never touch. So if you look on Desmos and you zoom out as far as you can and they never touch, that's going to end up being a parallel line. How can I tell if the lines are perpendicular? They have to have opposite. Remember, that means change the sign here. And reciprocal is a fancy word for flip. But they have to have both for the slopes. We still will count that rise over run again for both lines. Let's go ahead and start with the first line here. We're going to find 2 nice points right here. Count far up, plus 1, and how far over, plus 2. So that slope of that line is going to be up 1 over 2. I'll write it over here. Second line, let's find 2 nice points again. We go ahead and have one at negative 3 on the y-axis, and here, count down 2 to the right 1. That's going to be my slope here. As you see, I flipped those fractions, and I also made the sign change. So that's going to go ahead and be perpendicular. Visually, how you can tell as well, it's going to form 4 right angles. What I mean by right angles is at the intersection here of both my lines, I have perfect 90-degree right angle boxes as the intersection. Let's go ahead and try these in Desmos. So I'm going to put in the given point in Desmos for example number 7. So that point is going to be negative 1, negative 5. That's going to be my green point in Desmos. Step number 2 is I want to put in the given equation. So my given equation is going to be y minus 4 equals 3 parentheses x plus 2. And that's going to go ahead and be my purple line in Desmos. From there, I want to try each answer choice and eliminate any that do not go through the point or that do not have the parallel or perpendicular slope. So right away, I see this example says select the equation of the line that passes through -1, -5, and is parallel to the line. So I had to have the same slope as the line. Pulling the slope from the line when it's in point slope form, it's always the number in front of your parentheses. So my m, or slope, must be 3. Well, right away, you can also eliminate some here too because your slope is in front of the x here, and it must be 3. So right away, even before going to Desmos, I can eliminate b and d. But let's also see why in Desmos those don't work. So looking at example B, it was y equals 2x minus 3. It does go through the point, but as you see when I zoom out, they do end up meeting these two lines. And remember, parallel lines can never meet. Trying example D as our answer choice, as you see, it does not even go through the point, and it intersects the line, so it can't be parallel or the line suggested here. So I have A and C as my final options. Putting on both A and C, I can see only one of those goes through it, and that's my blue line of y equals 3x minus 2. So that's going to be C, not A, as my final answer. Next, example 8, select the equation of the line that passes through 2, 4. Again, that's going to be my green point, and is perpendicular this time to the line 3x minus 6y equals -6, and that will be my line in. For this example, I can't easily find the slope, so I'm going to go ahead and rely heavily in Desmos. So let's go ahead and try each answer choice. When I try answer choice A, it does go through the point, so I'm going to go ahead and keep that possibility. Example B does not go through the point, so let's eliminate that one right away. Going ahead and trying example C, let's go ahead again and see if that passes through. It does, good. So I'll keep that for a second, and then we'll look at D as well. So all of those that are left end up passing through the point. Now we just got to figure out which one's perpendicular. Well, let's look back at example C because right away these lines are never going to touch, which means that's a parallel case, not a perpendicular case. So let's get rid of our C, y equals 1/2 x plus 3. I have two options left, and let's toggle them both on in Desmos. Remember that visually perpendicular is going to be the exact opposite slope, and it's also going to make a 90-degree angle with the intersection here. So visually, you can see that this first line, option A, is not going to make a perfect box around your intersection. So therefore, it would be your option D of -2x plus 8. If you're still not convinced with the visual, we can go ahead and find the slope of these two lines here. How we count slope is we find two nice points on our graph. So let's go ahead and do that for the green line. One point's already given to us, and another one is perfectly down here. Counting down 1, 2 to the right one's going to make that -2 over +1 for our slope of the green line. Finding two nice points on our purple line is going to be at the y-intercept of 1 and the x-intercept of -2. We again count the rise, which will be +1 this time, over the run, which is +2. That slope is going to be 1 over 2. And as you see, between the two slopes, I did indeed flip it from 1/2 to 2 over 1 and switch the sign from positive to negative.